Let's walk through pull request 330617 for VS Code. This PR refactors how Windows builds verify their Authenticode signatures, switching from PowerShell to SignTool with more thorough validation. We're chasing two primary goals here. First, we want to validate all Authenticode signatures using SignTool's allFlag. Second, we need to enable this validation on Windows ARM64 agents. Along the way, we're also detecting test certificates, caching the SignTool path for performance, and bumping a build dependency. And we're preserving the public API contract so downstream test code doesn't break. Here's the problem this PR solves. PowerShell's getAuthentiCode signature only validates the outermost signature in a multi-signed binary, leaving a security gap where untrusted nested signatures could slip through. And on ARM64 Windows agents, SignTool wasn't even available. After this change, we're using SignTool with the all flag to validate every signature, and we're installing the Windows SDK build tools on ARM64 so the validation can actually run. Let's see where the changes live. The core validation logic is in the Sanity test context file, where we're replacing the PowerShell batch validation with per-file SignTool calls. The Azure Pipeline's YAML gets updated to install Windows SDK on ARM64 and pass the architecture parameter. And there's a small dependency bump in package.json. Here's the heart of the change. Before, we were calling PowerShell's getAuthentiCode signature in batch mode, checking if the status was valid. Now, we're switching to per-file validation with SignTool. The new approach discovers the SignTool path once and caches it, then invokes SignTool verify with the all flag to validate every embedded signature. And notice we're explicitly checking for test certificates with a regex pattern, so we catch those even if the agent's trust store would accept them. And that's how we close the signature validation gap. On the pipeline side, we're installing Windows SDK build tools on ARM64 agents. The YAML checks if the architecture parameter is ARM64, then downloads the NuGet package with retry logic, verifies the hash for integrity, extracts the SignTool binary, and sets an environment variable so the test code can find it. And we've replaced the custom ARM64 node download with the standard useNode task, which works across all platforms. That brings ARM64 agents into parity with x64 for signature validation. So where does that leave us? Every embedded Authenticode signature is now validated with SignTool's allFlag, closing the gap where nested, untrusted signatures could hide. Test certificates are explicitly detected and rejected. ARM64 agents have SignTool installed and can run the full validation suite. The SignTool path is cached for performance, and the public API is preserved so downstream test code doesn't need to change. There are a couple of things to keep an eye on. First, the error handling in the validation code checks spawn errors, then test certificates, then non-zero status sequentially. So if a test certificate is detected and the status is also non-zero, you'll only see the test certificate error. That's probably the right priority, but it means the status check is skipped in that case. Second, the Windows SDK version and package hash are hard-coded in the YAML. If the NuGet package gets updated, both values need manual updates, and there's no automation to detect a mismatch. This is a solid security improvement that closes the nested signature gap and brings ARM64 into parity with x64. I'd approve with a note to confirm the hard-coded SDK version aligns with other build constraints, and maybe explore automation for detecting SDK package updates down the road. Nice work.